Okay, so we have problem number 2. Excuse me. How far from the Earth must a body be along the line toward the Sun so that the gravitational pull of the Sun balances that of the Earth? Earth to Sun distance is 9.3 times 10 to the power 7 miles. Mass of the Sun is 3.24 times 10 to the power 5 times the mass of the Earth. So we have here the illustration. We have this object na patungaan siya between the Earth and the Sun. So it should be kuno in this problem, the gravitational pull between Earth and the object is equal to the gravitational pull between the object and the Sun. No? Balance. So we let x be the distance between Earth and the object. And so we are given the distance between Earth and the Sun. So therefore, this distance is, since naman siya sa between the two, ang distance now between the object and the Sun is s minus x. Okay, so we are given also, so this is our s. So other given, we have the mass of the Sun, which is 3.24 times 10 to the power 5 times the mass of the Earth. Okay. Now, unsa to'y giingon sa problem that the gravitational pull between the Earth and the object is equal to the gravitational pull between the object and the Sun. So, mo na siyang statement sa atong problem. And then from the formula, the gravitational pull or the gravitational force is equal to G m1 m2 over r squared. So substitute. So sa FG between ani nila, this is FGE. Ani both between the object and the Sun, this is FGS. So FGE, this would be from this formula of gravitational force, that is G, mass of the Earth, mass of the object, over ang distance between nila is x squared. Okay. While this one, G, mass of the object and mass of the Sun over s minus x squared. Okay, so we can cancel out G, common raman siya. Also, ang mass of the object ma-cancel. So, we have this one. ME over x squared is equal to ms over s minus x squared. While ang atong ms, by the way, ang atong ms is actually 3.24 times 10 to the power 5 times the mass of the Earth. So, over s minus x squared. So, ang mass of the Earth makancel ra gihapon dahil siya, class. So, kani siya atong i-cross. So, i-cross multiply na to ana niya. We have now s minus x squared is equal to 3.24 times 10 to the power 5 x squared. Then, raise both equation to 1/2. Square na to ang both sides. We will raise the power 1/2 or square root. We will get the square root of the both sides of the equation so that ma-cancel out atong squared. So we have now s minus x is equal to 3.24 times 10 to the power, sorry. Once again. We have x. Since square root man siya, ato siyang naa siya plus and minus, right? Plus and minus the square root of 3.24. Positive and negative root times 10 to the power 5. Negative and positive root. Okay, so we will transpose this x here. So s is now equal to, since negative, so siyang positive, plus x plus and minus the square root of 3.24 times 10 to the power 5. So this is now common si x. So ito ipagawa si x. 1 plus, we have square root of 3.24 times 10 to the power 5. So s therefore, no, we can now get the value of x if we transpose this one. So x therefore is s over this quantity. 1 plus positive and negative, the square root of 3.24 times 10 to the power 5. So kung atuang i-substitute ang value ni s, ang value ni s nga 9.3. So substituting the value of s nga 9.3 times 10 to the power 7 miles over 1 plus this one. That is plus minus na siya, class. X therefore, so whatever is the positive answer, you get that one since there is no distance nga negative. Okay, 163,097.81 miles. Okay. Number 3. If the pump discharges 75 GPM, so what is GPM? That is gallons per minute, of water whose specific weight is 61.5 pound-force per cubic feet. So you're given the gravitational acceleration of 31.95 feet per second squared. Find first the mass flow rate in pound mass per minute. Letter B, the time required to fill the vertical cylindrical tank 10 feet in diameter and 10 feet high. So you are given, what is 75? 75 gallons per minute, that is volume flow rate. Volume flow rate na siya, class. Volume ng 75 gallons. Niya kay naa may per minute. Mo na nga volume flow rate. Ang main kag flow rate na siya dot sa ibabaw. So main kag flow rate, that is per minute. So if this is volume flow rate, so na kay volume per minute na siya, class. That is equivalent for that. Gallons per minute. So we will convert this one to a more easier to solve na unit, no? So gallons, we will convert this to cubic feet. So we have 1 cubic feet, we have this conversion is 7.481 gallons. Okay, so this is now 10.025 cubic feet per minute. This is our volume flow rate. Then another given specific weight, gamma is 61.5 pound-force per cubic feet. You're given the gravitational acceleration 31.95 feet per second squared. Letter A, you are to find the mass flow rate. Nya, na siya term nga flow rate class. So, may hiskatag flow rate that is mass nga naidat sa babaw. So, meaning ana niya, that is, ang mass flow rate is actually mass per unit time. So, as you can see, this is mass flow rate, this is volume flow rate. Ang flow rate meaning per unit time. So, ang mass flow rate nato, it should be in unit of mass, pound mass, over unit of time. But ang minute, pound mass per so minute. Okay. This is our letter A. So, how do we get this one? From the formula of gamma, we are given the gamma, right? Gamma is, ano sa tanong gamma? Rho G. Right? Rho G. So, rho G over K. Use the proportionality constant. So, therefore, makuha ni mo sa density, that is gamma K over G. So, our gamma is 61.5 pound force per cubic feet. K na to is 32.174 pound mass feet per pound for second squared over the given nga gravitational acceleration 31.95 feet per second squared. So feet per second squared cancelled. You have the unit pound force is cancelled. So imuhang density now, you can obtain the density in the unit pound mass per cubic feet. So our density is 61.93. But ang gipangita is the mass flow rate. So from the formula sa density, density is mass over the volume, right? So kung maghisgot ang flow rate, density is mass flow rate over the volume flow rate. Aron ang flow rate or the per unit time nga unit is makancel out. So ang mass flow, ang gipangita nato is mass flow rate. So from that formula now, we can now have the unit, the formula for the mass flow rate, which is density times the volume flow rate. So density is 61.93 pound mass per cubic feet times the volume flow rate. We have 10.025 cubic feet per minute. So ang cubic feet na to ma-cancel out. So makuha na to ang mass flow rate, which is now in pound mass per minute. So dara, pound mass per minute. Okay, so that is now our mass flow rate. Kindly calculate 620.87. Now letter B. The time required to fill the vertical cylindrical tank 10 feet in diameter and 10 feet high. So from volume flow rate class, we are given the volume flow rate, right? Volume flow rate, unsa tanang volume flow rate? That is, as I have said, volume, wrong man eh. Ang akong gisigig mention is per unit time, pero M ang gibutang. So this is time, basta flow rate. Volume per unit time, okay? So that you can obtain the time now, which is volume over the volume flow rate. So we must get the volume of the cylindrical tank. So ang volume na to, from the formula, volume is area of the base times height, right? Then our base is a square, square naman, circle. Since cylindrical man siya, cylindrical tank. So that is pi d squared over 4 times the height niya all over the volume flow rate, which is na-obtainan natong volume flow rate there. This is given. So we have pi d squared, d is 10 feet over 4 times 10 feet ang height niya. all over the volume flow rate, which is 10.025 cubic feet per minute. So as you can see, cubic feet squared, then feet. So makancel out, cube na siya nga feet. So makancel out. So ang remaining unit now is in minutes. So time now is in minutes. 78.834. So more than an hour. That is the time required to fill the vertical cylindrical tank. Okay. Then we have temperature. So we'll have this last, the temperature. So by definition, the temperature is the degree of hotness or coldness of a body, and therefore the measure of intensity of heat. So when we talk about absolute temperature measured from absolute zero, that is the true temperature, and absolute zero, the temperature in which the molecules are believed to stop moving. We have the different temperature scales. We have 4. We have the degrees Celsius, we have the degrees Fahrenheit, we have the Kelvin, and we have the Rankine. Okay, so our absolute temperature scale for Celsius is Kelvin, and Rankine is the absolute temperature scale for degrees Fahrenheit. And then we have the relation between temperature scales. Relation between temperature scales. So we have here conversion. How do we convert temperature from one scale to another? We have temperature in Fahrenheit is equal to 9/5 the temperature in Celsius plus 32. And if you want to get the temperature in degrees Celsius, you simply have to multiply 5/9 times temperature in Fahrenheit minus 32. So you have to subtract 32 first from the temperature in Fahrenheit, then multiply that by 5/9. Then to get the absolute temperature in Kelvin, that is temperature in Celsius plus 273. To get the temperature in Rankine, that is temperature in Fahrenheit plus 460. Then other relations we have may temperature interval, or interval, and say that is change in temperature. This one, delta T, change in temperature that should be final minus the initial. So dili mo siya balihon, it should be final minus the initial. So if you can obtain negative delta T, what does it mean? If negative, so meaning to say ang iyang final temperature is less than the initial temperature. So ning cold siya, negative mo delta T. If you obtained a delta T nga positive, therefore ang imuhang final temperature is greater than the initial temperature. So kainit siya, from cold ning init siya, ning hot ning taas ang temperature. So ang imuhang delta T ana is positive. Now, for the relation of that, delta T in Celsius degrees. Sa Celsius degrees, ang degrees na to, ato ang gibutang sa front of the Celsius, so that it is to indicate that it is a change in temperature. Is the change in temperature in Kelvin. Temperature change in Fahrenheit is equal to the temperature change in Rankine. We have the temperature change in Celsius degrees is 5/9 the change in temperature in Fahrenheit. And the change in temperature in Fahrenheit, so mohara siyang i-cross, that is 9/5 the change in temperature in Celsius.